Hi friends, I am Sureshkumar. In this video, I am going to teach you how to remember hybridization. This topic comes under chemical bonding. So, what is the uses of hybridization? If you know the hybridization of the molecule, you can answer total number of bonds, total types of bonds, total number of lone pairs, geometry of or shape or structure of the molecule, bond angle of the molecule. Okay, you can answer any questions from this. What is hybridization? Hybridization is the mixing of atomic orbitals. Mixing of atomic orbitals, s, p, d, f. These are the atomic orbitals. The mixing of the atomic orbitals form hybrid molecular orbitals. So these are the types of orbitals: sp, sp2, sp3, sp3d, sp3d2, sp3d3. Okay, so what is the formula for hybridization? For calculating the hybridization or identifying the hybridization, we can use one formula here. The hybridization is equal to total number of bond pair or total number of sigma bonds in a molecule plus total number of lone pair electrons. So hybridization is equal to total number of bond pair electrons divided by or total number of sigma bonds in a molecule plus total number of lone pair electrons. Okay, this is the formula. So how can we identify total number of electrons in a molecule? So that is difficult. Total number of lone pairs, that is difficult. So I hope you know the Lewis dot structure or Lewis structure. So Lewis structure of molecule. If you know the Lewis structure of molecule, we can easily tell the hybridization of the molecule. For Lewis structure, we want to know the valency of central atom, and the bonding electrons in neighboring atoms. So valency of central atom and bonding electrons in neighboring atoms. So except oxygen and nitrogen, so all other atoms have one electron for bonding. For oxygen, bonding electron is 2. For nitrogen, bonding electron 3. So oxygen makes 2 double bond, nitrogen makes triple bond. Okay, so then how can we calculate the valency of atoms? For valency of atom, we want to know the group number. If you know the group of atom, central atom, we can easily we can easily calculate the valency of the atom. For first group, lithium, beryllium, second group, boron, carbon, nitrogen, oxygen, fluorine, neon. So first group, second group, third group, fourth group, fifth group, sixth group, seventh group, eighth group. Okay, for first group, valency 1, valency 1, second group 2, third group 3, fourth group 4, fifth group 6, sixth group 6, seventh group 7, eighth group valency 8. So based on this, we can identify the central atoms valency. Okay, so we know the neighboring group atoms and valency of atom. Okay, so based on this, we can remember this table. So periodic table is for S block and P block. Okay, so this is the first group, this is the second group, this is the third group, fourth group, fifth group, sixth group, seventh group, eighth group. So I am going to solve few questions. Based on the question, you can easily remember the hybridization. Okay, so hybridization, first start with the beryllium chloride, BeCl2. So beryllium comes in the second group, so valency is 2. Beryllium valency 2. Chlorine comes in the seventh group, but this is the neighboring atom, so always participate 1 electrons for the bonding. For chlorine, 1 electron, 1 electrons, one bonding electron, 1 electron is sharing for the bonding electrons. So we can write the beryllium central valency 1 2. For chlorine, Cl 2 3 4 5 6 7 6 7 1 2 3 4 5 6 7. So this is the bonding. So here hybridization formula, hybridization is equal to total number of bonding electron or sigma bond. This is the sigma bond. This is a sigma bond. Okay, total number of sigma bond plus lone pair of electrons. Total number of bond pair electrons or sigma bonds. Bond pair electrons or sigma bonds plus total number of lone pair electrons. Okay, so here bond pair electrons or sigma bond is 2. How many total number of lone pair electrons? There were no lone pair electrons in the central atom. There is central atom, there is no central lone pair electrons in the central atom, so 0 is 2. If the H is equal to 2 means sp hybridization, 1 s atomic orbital and 1 p atomic orbital hybrid to form sp hybridization. This is sp hybridization. So 2 atoms are contributing here. Okay, next bf3. So here boron is the central atom, so boron valence electron 3. So here I am going to use this dot form 1 2 3. For fluorine, chlorine, bromine all contribute 1 electron, so don't bother about that. Fluorine 1 1 1 1. So how many for hybridization? How many bond pair electrons? 2 or sigma bond 2, lone pair 0. So sorry, 3 plus 0, 3. 3 means 1s plus 2p. So sp2 hybridization. 1s orbital, 1s atomic orbital, 2 p atomic orbital, okay, mixed to form sp2 hybridization. Okay, then next CH4. For carbon valence is 4, 1 2 3 4. How many hydrogen atom? 4 hydrogen. Hydrogen atom valence 1 1 1 1 1. So hybridization H is equal to how many bond pair electron or sigma electrons? 4. Sigma 4 plus lone pair electrons 0. So 4 means 1s 3 p orbitals. So next together to form sp3 hybridization. sp3 hybridization. sp3 hybridization. Okay, NH3. Okay, I'm going to varying this nitrogen valency comes under group 5. So group 5, so valence is 5. Nitrogen 2 3 4 5. How many hydrogen? 3 hydrogen, 1 2 3. These 2 electrons form lone pair, put like this, lone pair. Okay, okay, hybridization H is equal to number of sigma bonds 1 2 3, lone pair 1, this is 1 lone pair. Okay, 4 means 1 s orbital plus 3 p orbitals, so sp3 hybridization. Then 5 H2O. Oxygen is the central atom, so oxygen comes in the sixth group. So sixth group, so the valence is 6. 1 2 3 4 5 6. So hydrogen 1 1, these two makes lone pair electrons. So hybridization is equal to how many bond pair? 2 bond pair. How many lone pair? 2 lone pairs. Total number of electron, total height is 4. So 1s plus 3p. So hybridization is sp3. Okay. So if positive charge is there, what will happen? Here nitrogen is the central atom, nitrogen. So nitrogen valence is 1 2 3 4 5, group number 5. So the valence is 5. So the positive means remove one electron. This you remove this from the molecule. One hydrogen, one hydrogen, one hydrogen, one hydrogen. So this removed. Okay. So hybridization H is equal to bond pair 1 2 3 4, 4 sigma bonds plus lone pair, no lone pair. So 4 s plus 3p. So sp3 hybridization. Okay. For 2 minus. So negative, example for negative. Here central atom is sulfur. Sulfur comes under the sixth group. So valence is 6. 1 2 3 4 5 6. Here 2 negative charge. So put 2 dots for negative charge. Extra 2 electrons. Here 1 electron removed. Positive charge, so 1 electron removed. Negative charge, so 2 electrons added. For oxygen, we already told oxygen form double bond. So one oxygen share with this, another oxygen share with this, one oxygen share with this, one oxygen share with this. Hybridization H is equal to, what is the formula? Total number of bond pair or total number of sigma bonds. Total number of sigma bonds. Here sigma bond is this is pi bond. Sigma, this is pi. This is sigma, this is pi. Sigma pi. So how many total sigma bonds? 1 2 3 4. 4. There is there any lone pair? No. So 4 means s plus 3p, sp3 hybridization. sp3 hybridization. Okay. For I3 minus, for iodine, I3 minus, iodine comes under 7th group. So 7 valence electron. 1 2 3 4 5 6 7. Here one valence, one negative charge, so put one negative. So iodine 1 2 valence, 2 valency, 2 iodine. These two form lone pairs, these two form lone pair, these two form lone pair. Okay. For hydrogen is equal to, hybridization is equal to 2 bond pair plus 3 lone pair. So 5 means s plus 3p plus 1d. sp3d. sp3d. Okay. Clf3. Here chlorine is the central atom. Chlorine 7 valence electron. 1 2 3 4 5 6 7. Okay. Fill up with the fluorine 1 2 3 4. 1 2 3. Lone pair is a lone pair. Okay. Hybridization is equal to bond pair 1 2 3, sigma bond 1 2 3, bond pair, lone pair 2. So 3 sigma bond plus 2 lone pair. 5 4 s 3p plus 1d. sp3d. Okay. So this is the variation. Okay. For nitrogen, one example I solve here. SNF3. SNF3. Here sulfur is the central atom. Sulfur comes under the 6th group. So 6 valency, 1 2 3 4 5 6. So here they give fluorine, that is fluorine 1 electron, nitrogen coordinate with 3 electrons. Okay, fluorine 1 2 3 fluorines, these 3 nitrogen. Okay, so hybridization H is equal to total number of sigma bonds. Here 1 2 3, this is sigma bond, this is pi bond, this is pi bond. So total number of sigma bond 4, plus lone pair 0. So 4 means 1s plus 3p sp3 hybridization. Okay, so in this way you can calculate the hybridization. If you know the hybridization, we can identify the geometry of the molecule. If you know the geometry of the molecule, we can tell the structure. If we know the structure, we can tell the bond angle. Okay, so in next video we will see how we can calculate, we can determine the geometry or shape from this hybridization and bond angle. Okay, I hope you like this video. Thank you.